I've been monitoring one wind farm at Mire for over 10 years, and another one at Mire, which has just finished the 5th year of monitoring. And I've been recording the habitat changes either on the infrastructure or adjacent to the infrastructure, or over a habitat management plan around it. If I take the Mire example, which is a spectacular one, we have a habitat management plan area around the wind farm which extends to 11 square kilometres. And in 5 years on that site, we have grown almost 3 square kilometres of new sphagnum on the area. And all we've done is just take off a relatively small number of sheep. Now, looking at the locations where the sphagnum is expanded, it's all on the relatively intact blanket bog surface in there. And it's overridden any existing drainage which is on the site. The breeding bird population of the site have largely collapsed over this 5-year period, and the bird surveyors are saying the site is now too wet for the nesting of breeding birds. The site is getting wetter, not drier. The underlying paradigm in your model is that the site will get drier in terms of the calculator. We could have the opposite happening, because my guess is that the turbines are capturing so much wind energy, it's reducing wind speed at the soil surface, it's reducing evapotranspiration, and the average water table is coming up as a result. The sites get wetter. So now, how do I get, if that is the correct supposition of what's happening, we need a peer-reviewed publication. What sort of documentation do I need to get done in as short a time as possible, which is going to be acceptable to the scientific community? Because this is simply not out there at the company.
No, why it's not included. But do you want me to answer? So a peer-reviewed publication, we have to base the evidence in here on peer-reviewed papers, otherwise we get criticised. So peer-reviewed publication giving us the change in water table depth, changes in evapotranspiration if possible to demonstrate this, changes in wind speed, the drivers which are causing this to happen at this site rather than other sites. So I mean that's difficult because we don't really know why it's happening at this site where it's not observed elsewhere. But we would need some idea of what drivers to include. It would need to be at a range of different sites. We would need evidence that the site wouldn't have got wetter anyway. So I guess you would need a site that was not in the wind shadow of the turbines nearby where it hadn't got wetter to demonstrate that that was due to the turbines. I mean, we would definitely need a strong demonstration that that was due to the turbines, and quantitative measures of how the water table depth changes with the particular drivers that we were talking about. That's quite a big ask, isn't it? It's yeah. But if it's a real effect, it could be something massive for the wind generators. I'm surprised people aren't knocking on your door asking you to do it.
Can I just add one thing to that and then put one question to the floor? The thing I wanted to say is that we have a research project that's going to start quite soon to basically test this hypothesis and reach this perspective independently, actually being aware of Tom's work on this. And we're going to monitor a site that has a wind farm on it and try and do a full sort of water table analysis as well as carbon fluxes versus an adjacent site that doesn't have a wind farm on it and is out with the wake of the wind farm where we'll measure the same parameters. And that project should start in October with about 2 years fieldworks, monitoring over 2 seasons and writing up the results after that. And that's still quite a long time for it to pay back into the calculator. So one thing that Joel will probably be interested in is whether any people who are working on wind farm sites have measurements of water table depth and control sites that you could actually consider this phenomena, to what extent it's valid. And we probably also would be looking for sites that hadn't had grazing on them beforehand as well.
Yeah, I mean, because there's the impact of the reduced grazing, which I guess again, well, if you were to actually measure the water table depth, then that's less prevalent. And then of course you've got compaction if you've got a lot of little hoops going in places. But in terms of the sphagnum density, that could actually be due to grazing, could it? Or was that not enough?
It's unlikely because as part of the monitoring for the sphagnum cover, we're talking now of annual walks of 25 kilometres in length, where you're recording every 100 metres how many sphagnums there. We've also been recording the amount of sheep dung and deer dung, etc. It simply doesn't correlate with the locations where the sphagnums are increased. Basically, you don't get many sheep on a blanket bog because there's not much to eat. They've got plenty of linear grass.
The real difficulty with working with these systems, and as I'm sure you're aware, is that they are living, breathing systems. So a peat bog will constantly be growing and shrinking independent of everything else that we do around it. So to actually get some sort of clear, definitive result that it is actually due to the wind farm, it's very difficult, isn't it? Very difficult to demonstrate that.
And there may be data that you have as well that could be really useful in this, perhaps not the control side, but any monitoring that's going on post
Do you know of any existing studies that
not apart from Tom's, I think.
so they're funding your project? Any others?
No, not that I'm aware of.
Right.
This is part of investment in looking at resilience and adaptation of landscapes to hosting land use.
And how many sites are you going to be
We can
looking
only do two. I mean, it's just limited by money. So one control and one wind farm site, and that's not ideal either, but it's some progress, I think, in considering aspects like this. Second question from SK Enviros: the embedded carbon in the site infrastructure, which I think can contribute to up to 10% increase in turbine lifecycle budgeting, is often flagged up as an issue. And is it possible to amend the model to include other site construction materials such as concrete, aggregates, steel and sand? We might have touched on this briefly.
It's kind of answered.
Yeah. So I called it an impact unconsidered, but it may actually be considered in the model, I just wasn't aware of it.
There's a way of doing it.
Yeah, see it done. Where did we put it? Yeah. Where is it? I've lost it. That's it, yeah, there we go. So, Dali derived some equations which she spoke about in her talk that can calculate this value from the values that are generally seen in different sites in the literature, but much better and recommended if you can get hold of that figure is to put in your own value. Now that value often comes from the part of the value comes from the turbine manufacturers, so you've got the infrastructure for the manufacture of the turbine, but that should also include the effects of concrete, you know, the input of concrete and the different aggregates and all that sort of stuff. So that should actually have been calculated offline. But perhaps, as we said earlier on, perhaps we should include a worksheet in here to calculate, to help you do that calculation. But we haven't.
And should you take it out to the grid, basically the point which you connect into the grid,
Yeah.
go away.
That should be accountable. Yeah.
And you can put in that presumably then operational fuel,
Pardon?
sort of construction fuel use and
Yeah,
things like that.
that
and
should all go
other
to
things.
there. But we don't do it. It's assumed that you've done that because, you know, this is just one number that you put in. So it's really,
You can get a developer's plan for that. Quite a large
Developments tend to not prefer stating one single turbine in an EIA.
sorry, what was that?
Developers don't tend to like taking it turbine specific because you don't know what's going to happen at time of EIA and time of construction. You know, you might be held to that. And just
So
give
they
a
don't-
range.
They don't specify they're going to use Vestas.
It's normally just a hub and tip and a minimum installed capacity, and you might talk about your maximum grid capacity and give a range.
Yes, may have no idea where your grid connection is actually specifically going to be. You may know what line it's going to be on, but you don't know where it's going to be. And that planning and design process may be